check out some applications on compound interest problems, banking type problems, as they're sometimes mentioned. Got a couple of formulas that we'll need to solve these problems. And they're used under different circumstances. This first formula is used to calculate compound interest when your interest is compounded n times per year. N times a year means if your interest is compounded quarterly, that means 4. Annually, 1, and so on. Excuse me, when your interest is compounded n times per year, we use this formula, and we've described below what the different variables represent. A is the amount in the account after it's been left for t years. P is the principal amount that's been invested. R is the interest rate that must be given as a decimal. So if it's a 7% interest rate, you have to convert it to 0.07. Or 3.25 interest is converted to 0.0325. Got to convert that interest rate. T that you see in the formula is time in years, and N is the number of compoundings per year. And I've mentioned here, monthly means N is 12, quarterly N is 4, daily, annually, and so on. So your value of N will vary based on these wordings. Let's kind of look at them all at one swoop. We've got $1,000 we're going to invest. We're going to invest it. Boy, did I just invest a whole bunch of money at an interest rate. We could look at that. I really don't want to look at that. Let's just do $1,000. Sum of $1,000 is invested at an interest rate of 9% per year. Find the amount after 10 years if interest is compounded, given these 4 scenarios. Well, let's go identify some data here. This 1,000 represents which letter? The investment, which is the principal. This 9% represents interest rate as a decimal, 0.09. Find the amount in the account after 10 years. 10 represents what? It's got to be time in years. Now let's check out if interest is first compounded annually. If it's compounded annually, that means it's done once a year. Semi-annually, twice a year. Quarterly, 4 times a year. Now this thing here says continuously. Well, whoa, I've got to back up because I never mentioned the continuously deal. If we have to calculate compound interest and it's described as the interest is compounded continuously, we bypass all this middle part with the n and the 1 plus, and we come up with the formula A equal to P times e to the RT power. So if they say continuously, in my mind I say, okay, I'm using the PERT formula. So this word formula actually should have been under here, which says use the different formula. So continuously says, all right, switch modes, use the PERT formula. Otherwise, if it doesn't say continuously, we need to use the longer version. So I have to use the A equal P times 1 plus R over N raised to the NT power. But I know all my information, so all I have to do is plug it in. 1,000 times 1 plus the interest rate, 0.09. N is 1 to the 1 times 10 power, 1 times t. Then we let the calculator do the rest of that. So let's clear all this out. And let's type in the 1,000, parenthesis, 1 plus 0.09 divided by 1, and that's all raised to, use the caret, always put parentheses on the exponent. Otherwise, it'll only take the 1 as the exponent and not the 1 times 10. Well, let's enter it. We're going to look for dollars and cents here, and I get a total of, I don't want to do that. Oh, never mind, I can't. 23.67.36. 23.67.36. So yeah, we'll put some decimals here because we're dollars and cents. Now, what's nice is we can use the feature I mentioned earlier with our calculator. To calculate this next one for semi-annually, all I have to do is change this 1 to a 2. Second entry retypes what I have. I can go up in here and change that 1 to the number 2. And come down here and press enter, and it's 5604.41. 5604.41. So if it's done twice a year, that would be our calculation. Quite a difference. What was the other one? Quarterly, 4 times a year. So let's do the same thing. Let's do second entry, and let's change the 2 to a 4 and make it quarterly. Oh, I knew I forgot something in my formula. This is R over N. When I changed my formula over here in the second one, I forgot to change that 1 to a 2. This 1 should be a 4. Let me go back and make that correction, and I'll correct the middle one. It's 1 plus R over N raised to the NT power. So these two numbers should both be 4. And that's where I made my mistake earlier. 24, 35, 18. Thought that middle number seemed a little high. Let me do the middle one again, but change both values. The 2 that are the 4, these should both actually be 2, where the mistake I made earlier is I forgot to change the first one to 2. Okay, that should be a 2, and that should be a times. Now this number should be in reason. Yeah. 2411, and I lost that one, 71. So pardon me on that mistake. Always watch your values. When you're doing this type of problem and you're doing it that way, these two values of n both have to be changed. Well, when they say continuously, you jump ship and you go to the next formula. A is equal to P e to the RT. Not quite so much to fill in on this problem. 1,000 e raised to the interest rate, which is 0.09, times time, which in this case is 10. So we'll go on our calculator. Figure out what we had. 1,000 e to the 0.09 times 10. Oop, too many zeros. $1,000 times e raised to the 0.09 times 10 power. Now this is continuously. What we end up with is 2459.60. Let's compare. interest is done once a year, we earn $23.67. If it's done twice a year, does it make sense we earn a little bit more money? Sure. If it's done 4 times a year, we earn even more money. Not a lot, but notice we're earning more money. When I jump to the continuously account, that means interest is compounded every second of every day of every year, and you end up with $24.59.60. This is pretty much the max that you could make if you have it in an account, following all these guidelines in an account that earns interest continuously. Not a huge difference, but if I'm given a choice, I want the account that's going to give me the most money. Now, obviously, this works against you when you're buying a home or a car or something like that. Let's play a game. Let's choose between 2 investments. So we have a principal, $8,000, and we have a time, 6 years. We've got to choose between 2 accounts. We've got a 7%, that's monthly, a 6.85 continuously. Let's see who's going to be the better investment. So let's go with the monthly. N is equal to 12 when we're doing monthly. 8,000 times 1 plus interest rate 0.07 divided by N, which is 12, raised to the 12 times 6 power. If it's done continuously, it'd be 8,000 times E raised to the R, which is 0.0685. Change that rate to a decimal. E to the RT. So that's the R times the T, which would be 6. So this monthly account at 7%, or this continuous account at 0.0685%. You do the math. $12160 plus some change. And this one is 8,000 times E 0.0685 times 6 years. 12066. Change. Which would be the better investment if you were given the option? Clearly, the one that gets you the most money would be the better investment. Now, remember, we said continuously is the one that's going to give you the most money, but there are also other factors such as number of times it's compounded, and more importantly, the interest rate. So check out the assignment in the book, some applications, technology, critical thinking problems there, and I'll close 4.1 with that.